Assalamualaikum and hi ladies and gentlemen. Welcome to today's presentation on the critical topic of chemical hazards and uncontrolled fertilizing in agriculture. My name is Nasabrina binti Rusti and I will be your guide through the discussion. Chemical hazard refers to the potential risk or danger posed by exposure to chemical substance. These hazards can arise from various sources, including industrial process, household products, environmental contamination, and accidental spills. These hazards include toxicity, flammability, reactivity, corrosivity, carcinogenicity, mutagenicity, and teratogenicity. Chemical hazards are typically assessed and managed through various means, including regulatory standards, safety protocols, labeling requirements, and training programs to minimize the risks associated with handling, storage, transportation, and disposal of hazardous chemicals. Uncontrolled fertilizing refers to excessive or improper application of fertilizers in agriculture or gardening without proper consideration for the needs of the plants, soil health, or environmental impacts. This can lead to a variety of problems, including nutrient runoff into waterways, soil degradation, groundwater contamination, and damage to ecosystems. When fertilizers are applied in excess, the nutrient not absorbed by plants can leach into groundwater or run off into nearby water bodies, causing eutrophication, which is the excessive growth of algae and other aquatic plants. This can lead to a decrease in water quality, loss of biodiversity, and harm to aquatic life. Uncontrolled fertilizing can also disrupt the natural balance of nutrients in the soil, leading to nutrient imbalance that can inhibit plant growth or make plants more susceptible to pests and disease. Let's start by addressing the overuse of chemical steel in agricultural activities. This practice has significant implications for crop quality, water quality, and soil health. Many farmers apply chemicals still hazardly, relying more on experience than scientific expertise. As a result, we see risks such as plant failure, water contamination, and soil nutritional imbalance. To mitigate these detrimental effects, we advocate for a paradigm shift in conventional agricultural practice. This includes embracing enhanced technological measures, optimizing processing formulas, and promoting ecologically acceptable alternatives such as biological and organic steels. Moving on, we delve into the specific challenge faced in agricultural lands around Cameron Highlands. Excessive fertilizer usage, compounded by the extensive use of rain protection structure (SPH), has led to the degradation of agricultural lands. This has resulted in poor soil fertility and texture, posing a threat to the long-term viability of farming in the region. To address this issue, it's crucial to implement measures such as creating pause intervals for soil fertility recovery and allowing rains to dilute stockpile fertilizers by opening SPH structure. However, restoring fertility may be challenging if the ground has been heavily exploited without sufficient rest and care. Lastly, we discussed the broader ecological impacts of nitrogen fertilizers. While these fertilizers play a crucial role in the post-World War II agricultural revolution, their extensive use has led to runoff and water pollution. Climate change exacerbates this issue with change in precipitation patterns, increasing agricultural runoff and nitrogen pollution in water bodies. The consequences of nitrogen pollution are far-reaching, affecting areas such as the Northeast, Great Lakes Basin, and Gulf of Mexico. Sustainable solutions are urgently needed to mitigate these impacts and ensure the health of our ecosystem. The overuse of chemical steel and nitrogen fertilizers poses significant challenge to agricultural sustainability and ecosystem health. However, by implementing sustainable practice, optimizing fertilizer usage, and embracing ecological alternatives, we can mitigate this challenge and pave the way for a more resilient agricultural sector.
Hi and Assalamualaikum. My name is Nur Ali Ishrabati Afandi, and today I want to present about the reason or possible causes which contributed to the hazard or danger in the case or article that can have adverse effect on workers. Firstly, inadequate knowledge and instruction among farmers. It's alarming to note that many farmers lack the necessary understanding of how to properly apply chemical fertilizers. This ignorance leads to incorrect application, over-fertilization, and ultimately soil degradation. Without adequate training and instruction, errors made by farmers compromise both soil health and agricultural output. Secondly, we have the issue of overuse of chemical fertilizers. Farmers often rely excessively on this fertilizer without considering organic or alternative options. This over reliance exacerbates the problem of excessive fertilizer usage and nutrient imbalance in the soil. Without a full understanding of the long-term effects, farmers may opt for chemical fertilizers out of convenience or perceived benefit. Last but not least, insufficient oversight and guidelines pose a significant risk. The lack of appropriate supervision and control over fertilizer usage allow for potential abuse by farmers. This can lead to environmental harm, water contamination, and reduced agricultural output. Unsustainable farming method persists when the rules and guidelines are not enforced. To begin with, we have unsuitable farming methods. The persistent and excessive use of fertilizers by agricultural operators in Cameron Highland is the primary culprit behind the hazard. These farmers apply large amounts of fertilizer without proper control, driven by desire for higher yields or a lack of awareness of sustainable practices. Unfortunately, this inadequate method of farming leads to soil degradation, rendering the land unsuitable for cultivation and jeopardizing farmers' livelihood. Secondly, a poor understanding of environmental effects exacerbates the issue. Many farm operators lack knowledge by how their actions impact the environment. Driven by short-term profit, they prioritize immediate gains over long-term sustainability. This often results in excessive fertilizer use and neglect of soil protection measures, contributing to environmental pollution and soil destruction. Last but not least, insufficient enforcement of regulation further escalates the risk. The lax implementation of rules and standards regarding fertilizer usage allows unsustainable practice to persist. Without proper enforcement, operators may lack motivation to reduce fertilizer use or adopt alternative techniques. This ina- this, ina- this ineffective regulation exacerbates soil and environmental degradation. Firstly, pattern of precipitation altered by climate change. The primary danger stems from the shifting precipitation patterns induced by climate change. This alteration increases the amount of nitrogen runoff into water bodies from farms. Warmer temperatures leads to greater agricultural runoff and heavier rainfall, resulting in surplus fertilizer nutrients being dumped into rivers, lakes, and the ocean. This phenomenon poses significant risk to aquatic ecosystem and human health, exacerbating eutrophication, toxic algal blooms, and dead zones in coastal water. Moreover, the overuse of fertilizer compounds the problem. The excessive application of nitrogen-based fertilizers beyond what crops require for growth is a significant contributing factor. When farmers apply fertilizer haphazardly or in excessive quantities, excess nutrients are left behind and wash into water bodies during rainy season. This rampant fertilizer use contributes to water pollution and ecosystem deterioration, reflecting a lack of understanding or concern for the environmental impacts of agricultural activity. Thirdly, inadequate climate change adaptation further amplifies the risk. Agricultural techniques often fail to adapt to the changing climate conditions, particularly in terms of increased precipitation and nutrient runoff. Farmers and agricultural officials may struggle to plan for or foresee these changes, leading to heightened risk of eutrophication and its associated effect. Efforts to minimize nutrient pollution, such as improved fertilizer management and conservation techniques, are crucial for maintaining water quality and agricultural output.
Now, we'll be discussing the diverse routes of entry for chemical hazards arising from excess fertilizer use in agriculture and the implications for environmental and human health. Let's start by exploring the potential routes of entry for chemical hazards in agriculture setting. One significant route is soil absorption, where overuse of fertilizers allows chemicals to seep into the soil, potentially contaminating groundwater and harming water quality. Additionally, surface runoff from irrigation or rainfall can carry these chemicals into nearby bodies of water, exacerbating water pollution concerns. Aerosol drift, particularly from spray or dust form of fertilizers, disperses chemical particles into the air, posing risks to human health and adjacent ecosystems and impacting air quality. Another area of concern is the bioaccumulation of chemical hazards in plants. Chemicals overexposed in the soil due to overfertilization may be observed by plants and accumulate in the edible portions of crops. This poses risk to consumers' health, highlighting the connection between agricultural practice and human well-being. Additionally, tainted irrigation water, regardless of its source, introduces chemical risk into the agricultural system, affecting crop safety and soil condition. It's crucial to address this risk associated with irrigation techniques to ensure the safety and quality of agricultural products. A particular case study highlights the issue of runoff from large-scale flower farms that utilize rain protection structure (SPH). These structures prevent precipitation from reaching the soil, leading to an accumulation of nutrients inside the SPH and negatively impacting soil texture and fertility. Subsequent runoff from these structures introduce chemical risks into the surrounding environment, exacerbating environmental concerns. Effective countermeasures must address these different channels of entry, emphasizing the importance of sustainable agricultural practice. The diverse routes of entry for chemical hazards in agriculture underscore the need for sustainable farming methods to mitigate the negative effects of excessive fertilizer use. By addressing this challenge, we can protect the environment, public health, and agriculture. It's imperative that stakeholders collaborate to implement sustainable solutions and promote responsible fertilizer management practice.
I'm going to addressing the critical issue of environmental hazard associated with agricultural practice, particularly in the context of climate change. Firstly, Article 1 underscores the risk to human and soil health associated with the overuse of chemical fertilizer. These risks include plant failure, water pollution, degradation of agricultural products, and imbalance in soil nutrients. Over-fertilization leads to the build-up of chemical salts in the soil, altering its physical and nutrient composition. This not only harms food quality but also diminish agricultural productivity. Furthermore, surface and groundwater contamination by field runoff can lead to eutrophication and ecological harm. To mitigate this hazard, the article recommends the use of micro and biological fertilizer to provide balanced nutrients and improve soil health. Moving on to Article 2, it highlights the adverse effect of fertilizer overuse in Cameron Highland. The extensive application of fertilizer has led to deteriorating soil quality and the emergencies of dead soils. Compounding the issue is the widespread use of rain protection structure (SPH), which inhibit natural process like rainfall that could help alleviate fertilizer buildup. The overabundance of fertilizer renders the soil unsuitable for farming, posing a significant threat to the livelihoods of local farmers. Soil fertility restoration is uncertain and requires substantial time and effort. Thus, better control and management of fertilizer usage are imperative to minimize soil deterioration and preserve sustainable farming system. Last but not least, Article 3 examines the impact of climate change on nitrogen runoff from agricultural fertilizers, leading to eutrophication and toxic algal blooms in water bodies. The study predicts significant increases in nitrogen runoff due to climate change-induced higher rainfall events, posing a serious threat to ecosystem health and water quality, particularly in coastal areas already affected by nutrient contamination. In light of these findings, effective assessment and control strategies are necessary to mitigate the dangers associated with nutrient contamination and safeguard water resources for future generations.
Hello everyone, my name is Noah Zemi. Today I will discuss the critical importance of implementing control measures for hazardous substances to protect the environment, the community, the health and safety of workers. Chemicals play a vital role in various industries, but their improper handling, storage, and disposal can pose significant risk. Let's explore the key steps involved in managing hazardous chemicals to mitigate these dangers and ensure compliance with safety regulation. We go with the first one, which is substitution. Substitution is a preventative measures such as replacing harmful compounds with less damaging alternative. Substitution not only minimize environmental impact, also reduce exposure hazard, improving sustainability and protect the public health. The second one, engineering controls. Engineering controls entail making physical changes to facilities and processes to reduce or eliminate risks. Containment system, ventilation system, and process enclosures are essential to prevent hazardous material from leaking into the workplace. Process adjustments such as modifying operating parameters help to reduce the production or release of hazardous chemicals. Ventilation systems and enclosures keep airborne pollutants out of the air, ensuring worker safety and environmental protection. And the third one, monitoring and evaluation. Routine monitoring, inspection, and evaluation are necessary to maintain the effectiveness of control mechanism. Regular assessment of exposure levels, chemical concentration, and air quality helps detect and correct any defects or risk. So, based on my observation, substitution emerges as the most essential step in hazardous substance control. By addressing the underlying sources of exposure hazard, substitution significantly reduces the potential for negative health effects and environmental damage. Substitution eliminates the needs for complex safety procedures and control measures related to hazardous material, resulting in better working conditions and productivity. Long-term cost reduction are possible, including such as lower healthcare expenses, waste disposal costs, and regulatory compliance fees. So, in conclusion, effective control measures for hazardous substances are vital for protecting the environment, the community, and workers' health and safety. By implementing preventative measures, engineering control, and regular monitoring, organization can mitigate risks and ensure compliance with safety regulation.
Assalamualaikum and very good morning to everyone. My name is Anis Nabila Binti Ahmad Khanzi. Today, I will delve into the critical issue of managing environmental risk associated with the extensive use of chemical fertilizer. We will explore how regulatory framework in the United States play a crucial role in addressing this risk and safeguarding our environment. Let's start by understanding the specific hazard linked to chemical fertilizer like soil degradation, water pollution, and eutrophication. One of the cornerstone regulations in the U.S. environmental protection landscape is the Clean Water Act (CWA) of 1972. Enforced by the Environmental Protection Agency (EPA), the CWA regulates contaminant discharge into U.S. navigable water and sets surface water quality standard. Under Section 303 of the CWA, the program for water quality standard is defined, including regulation for nutrition like phosphorus and nitrogen. This section plays a crucial role in preventing eutrophication and maintaining water quality. The CWA NPDES program control point source contamination by issuing permit to regulate pollutant discharge into water body. This mechanism help in curbing water pollution arising from chemical fertilizer runoff. Addressing groundwater pollution is a key aspect of environmental protection. The Safe Drinking Water Act (SWA), overseen by the EPA, ensure the protection of underground drinking water source from pollution and set guidelines from drinking water quality. Through this state and regulation, a comprehensive framework is established to manage environmental risks associated with chemical fertilizer. By controlling pollutant discharge and safeguarding water quality, this regulation mitigates the risk of eutrophication, soil degradation, and water pollution. In conclusion, regulatory frameworks such as the Clean Water Act and the Safe Drinking Water Act provide essential tools for managing the environmental risks posed by the overuse of chemical fertilizer. By adhering to this regulation, we can protect our natural resources and ensure a sustainable future. Thank you for your attention.
Once again, thanks for the meetup and hopefully we can meet again soon in the future. Bye bye!